All right, let's get right into it. We're going to pull back the curtain on the invisible technology that pretty much powers our entire connected world. It's called orthogonal frequency division multiplexing, or OFDM for short. And honestly, it's the secret language your devices are using to talk to the internet right this second. I mean, have you ever really stopped to think about that? How on earth does your Wi-Fi get a massive 4K movie through walls, past other signals, and through all sorts of interference, without it turning into complete gibberish? It's a fantastic question, and it gets right to the core of a huge challenge in communication, sending tons of data super fast and reliably through thin air. To really get why the solution is so brilliant, we have to understand the problem first. And the real problem, surprisingly, isn't just about speed. It's about the echoes that speed creates. So, here's the main villain of our story: intersymbol interference, or ISI. The best way to think about it is like shouting in a canyon. If you talk slowly, each word comes back as a clear echo. But what happens if you start shouting really, really fast? The echoes of your words start to pile up and smear into each other, and pretty soon it's just a jumbled, unintelligible mess. Well, the exact same thing happens to your data. You know, for the longest time, the approach to going faster was pretty simple. Just send the data harder and faster down one big single radio channel. Just brute force it. But it turns out this approach has a massive, fatal flaw when you're dealing with the real world of wireless signals. What's really cool is when you frame this whole thing as a delivery problem. Okay, so on one hand, you could use one super fast truck to carry a single, giant, fragile package. Or you could use a whole fleet of slower but much sturdier vans, where each van is only carrying a tiny piece of the package. And this just perfectly illustrates the weakness of that single signal approach. See, a wireless channel isn't some perfect, smooth superhighway. It's more like a bumpy road filled with potholes. These are specific frequencies that get blocked or faded out. Now, if our one super fast truck hits just one of those deep potholes, boom, the entire package is ruined. The whole delivery is a complete failure. Okay, so if sending one big fast truck is way too risky, what's the alternative? Well, the answer is to stop thinking about one truck and start thinking about a whole fleet of signals. And this is the big aha moment behind OFDM. Instead of trying to solve one massive high-speed problem, you just create thousands of tiny, slow, and totally manageable problems. You chop the data up into little pieces, you put each piece in its own van, and you send them all out at the same time on thousands of parallel roads. So now if one van or even a few vans hits a pothole, it's no big deal. You only lose a tiny little piece of the data and the rest of the package gets there perfectly. It's genius. And what's really incredible is that people were already figuring this out way back in 1967. Pioneers like Salzburg realized the secret wasn't to build some kind of indestructible super truck. No, the real magic was in making the whole fleet of vans work together as efficiently as possible, basically making sure the vans didn't crash into each other. Now, this fleet of vans idea is fantastic in theory, but turning it from a cool concept into the tech that powers your phone, well, that took 3 huge breakthroughs. I like to call them the 3 magic tricks of OFDM. Magic trick number 1 is something called orthogonality. This is some serious mathematical wizardry that lets us paint the lines for all our parallel roads. It lets us pack thousands of these channels so incredibly close together that they actually overlap. But here's the crazy part. They're designed so that at the exact, precise moment the receiver listens to one road, all the other roads are perfectly silent on that frequency. It's like having a perfectly timed conversation where everyone talks at once, but you only hear the one person you're trying to listen to. It's just unbelievably efficient. Okay, trick number 2 is the engine that makes this whole fleet run, the fast Fourier transform, or FFT. This thing is a brilliant piece of software, a hyper-efficient algorithm that basically acts like a digital prism. It can take one big stream of data and, in an instant, split it into thousands of individual signals for all our little vans. And then it does the exact reverse at the other end. Seriously, without the FFT, trying to manage this many signals would be totally impossible. And the third trick, this might be the cleverest one of all. It's called the Cyclic Prefix, and it's what finally beats that echo problem we talked about. It's so simple, it's beautiful. Before sending a block of data, the transmitter just copies a little bit from the end and pastes it onto the beginning. That's it. This one simple move means the echoes from the last block of data fall harmlessly into this copied section where the receiver can just ignore them. It takes the biggest problem in wireless communication and just makes it vanish. So with those three magic tricks in the bag, OFDN went from being this fascinating idea on a chalkboard to being the absolute bedrock of modern digital communication. And you can just see its journey here. It started as pure theory back in the 60s, and it kind of simmered for a few decades. Then, once computing power got cheap enough in the late 90s and 2000s to actually run that FFT algorithm on a little chip, it just exploded. ADSL, then Wi-Fi, then 4G LTE for billions of people. I'm not kidding, just look around you right now. The Wi-Fi you're probably using to watch this, that's OFDM. The 4G or 5G signal on your phone, also OFDM. Digital TV, digital radio, even older DSL internet. It's all speaking this one powerful, unseen language. So after all that, what's the big takeaway? Why does any of this really matter? The true genius of OFDM is this. It takes the messy, complicated, unreliable physics of one wide radio channel, and it transforms it into thousands of simple, clean, and incredibly reliable little channels. It cleverly trades one giant, fragile problem for thousands of tiny, robust ones. And in doing that, it makes the high-speed wireless world we all take for granted actually possible. So yeah, OFDM basically conquered the challenges of its era. But what's next? The really exciting new ideas are building right on top of this foundation. People are asking questions like, what if the choice of which van we use, what if that could carry data too? It's a mind-bending idea called index modulation, and it hints at a future where our wireless tech gets even more clever and efficient. But that's a story for another time.